Alright, it's time for another math easy solution. We're going to discuss well further into Newton's method on linear approximations, which I showed in my earlier video, and this time do examples on it basically and look at part one of this example series on where Newton's method converges or works properly, and then next time I'll do one on where it doesn't converge properly or it takes really long to converge here. So now let's recap on Newton's method. So if you had a function like this, we'll call this f of x here, and you want to approximate or basically calculate this root, and if it's a complex equation it's hard to get the root. So basically in this kind of, you want the root where it's equal to 0, find where x is. What you would do, you would pick an initial starting x value, so we'll call this x1 here, and then you would use the derivative of this function here at this point that you initially chose, and you basically draw a tangent line. It'll be across this whole thing, and then you get a second point here, and it's closer to this. Let's call this x equals r, or the root. So basically then you know that this derivative here, so you use this equation of a line to determine what x2 is, and it's closer. Then it's an iterative process. You keep doing this over and over again, and you know that this is rise over run here. So the derivative at this point, f of x1 is equal to, well, rise over run in this case. And the rise of run is going to be, well, in this case it's 0, so it's 0 minus f of x1, because remember you're going down here, and this is the run here. At this point here is f of x1, and then divided by, well, the run, which is x2 minus x1. Then if you rearrange this to solve for x2, you get basically x2 is equal to x1 minus the f of x1 divided by the derivative of f of x1 here. F of x here. So then you have this one here, and you keep doing this and over again, you're going to get basically an iterative process. You go n plus 1 equals to xn minus f of xn divided by f prime of xn here. And because you could keep doing this one here, so this will be the new starting point, and then you get a new x3 here, and it's closer and closer. You keep doing it until you get to it. So that's basically Newton's method recap from last video. So now let's do some examples here. Let's go example 1. So this example 1 is basically x cubed minus 2x minus 5 equals 0, and basically use Newton's method to approximate what the root is, well, basically when x1, the starting point is equal to 2 in this case. So you could use graphing, like Google graphing or whatever, just graph it and then use your calculator to graph this side, and then look when it crosses 0 and zoom in and find it. Well, that's tedious, so to find out what this root is, well, we basically we were given that f of x here equals 0 in this case. We'll just let f of x equals x cubed minus 2x minus 5 here, and then the derivative in this case is just equal to 3x squared minus 2. Yeah, this is the derivative here. So then we just set up our little equation here. Xn is equal to, xn plus 1 is equal to xn, and this is going to be a minus f of x. We just put the xn inside all of these ones here. So we're going to get xn 3 minus 2, so 3, yeah, xn minus 5 divided by the derivative, and this is, we'll just put this in brackets here, this is 3xn 2 minus 2. So you could plug in as x1 is equal to 2 here, and then get x2. And well, you could, what I'm going to do is use Excel here. So here's Excel. I'll show you how to make a quick, easy table here to get it here. So basically, this is xn. We'll just let this equal to 1 as initially, and then this one is going to be equal to, yeah, this one is just equal to the function here. This is xn, in this case 1 to the power of 3 minus 2 times xn minus 5 here. Then you do the same with the derivative. Yeah, and you just write 3 times, well, x to the power of 2 minus 2. And then this new x1, this one is going to be our equation, which is going to be xn minus f of xn divided by f prime of xn. So we get a number here, and we get a 7 here. And then here's a quick method to just press Control T or make it a table. So my Excel has table here. Change the style right here. Now if you just press Tab, now this next one number is going to equal to this here. And well, now it's 4.6765. So as you can see, it's getting closer to a number. But now here's a quick way to automate this, because this is an equation, this isn't. So we just scroll through this one here, scroll it up as well, and then you press a, or just scroll this down again. So now every time you go a new tab, it is going to automate everything. So now it's automated there. So we keep going. Yeah, and remember, we're trying to get this f of x n equal to 0, because that's when the points intersect, or the roots, because that's what the right side's equal to. So we keep going. As you see, e to the negative 10, so it's getting really close. So basically we got all the way up to here, and as you can see, it's 0. So we have, this is pretty accurate here, of 2.0945. Oh, whoops, I made a mistake here. The initial was 2, not 1 in here, but you can see it still converged here. It took a while here. So if you put a 2 in here, and as you can see, it converges much quicker here if your starting point was more accurate here. And as you can see, it's the same number, 2.09455148, and then you could, depending on how accurate you want to keep going down, but it's pretty close. Yeah, this is 0, basically what Excel considers 0. And x2 is basically 2.1 here. Yeah, I'll just write that down here. And x root is basically, we'll just say it's equal to 2.09455514, etc. So basically, yeah, that's our root there. Now example 2 basically is solve this one right here, square root of 2 to the power of, well, 1 over 6, or 6 root 2, I'm not sure how to write it. Basically this is just 2 over 6. And you could, if you use Newton's method here, you can remember, you could just rearrange this as the answer to this equation, x to the 6 minus 2 equals 0 here. Because remember here, then if you just rearrange this, you're going to get x6 equals to 2, and x is equal to, well, this is square root, 6 here. So you could write this as this. This is a neat little trick here. And now if we do the same thing as above here, we know xn plus 1 is equal to, well, xn minus, and then the minus, this one's going to be equal to, well, this is x and 6 minus 2, and then the derivative. The bottom is going to be the derivative, which is 6 x n to the power of 5 as a derivative of this one here. Now we just plug this into Excel. So yeah, if we plug this into Excel and we use a starting point of 1 in this case, we see that you get xn is 1.16, and it converges pretty fast here, and we get a number of 1.122 and whatnot. So this is, yeah, so we get this number. Yeah, for x1 equals to 1, we get up to x6, the 6th iteration, we get 1.12, and this is, yeah, basically roughly equal to the root here. So you can see it's pretty quick and easy, especially using with Excel here. So now last example for today, basically this one, example 3, cos of x minus x equals 0. Basically find the roots using Newton's method here. And we'll recall that this one is, if you rearrange it like this, cos x equals x here, and then if you were to draw something like this, yeah, if you were to draw something like this one here, this is a cos x, roughly how it looks like, and then the equation of x here, because remember it has to intersect, it's going to be something like this. This is y equals x here, equals x curve in this case. And then this one here, well, we could just roughly approximate this one, because remember this is pi over 2 here, where it's equal to 0, and this is at, I mean, this is, yeah, just 3.14-ish divided by 2, so it's a bit more than 1. So it's greater than 1 here, so we could use an approximation as 1 in this case here. So yeah, when you graph this with Google Graphing or Graphing Calculator or whatnot, and you zoom in, as you see, this one is close to, we chose 1 for this one here, but if you zoom in further, you can see that this is closer to 0.75, so if you use a graphing device, you could probably have a better approximation to start here, but we're going to do both of them here. So in this case, we could do, let's go, yeah, we could choose part A as x equals to 1 here, and part B x1 equals 0.75, and to see how fast they converge. Now pulling out the graphing table that I made, or just with Excel here. So basically I have a table here. This one is the cos function in this case. Oh, well, and I forgot to, first I gotta get the derivatives in there, because basically f of x in this case is just gonna be cos x minus x, and f prime of x equals to negative sine of x minus 1 here, and we just basically plug these into Excel. So in Excel here, this equation basically cosine of, well, the xn here minus xn, and then this equation, this is just sine of xn minus 1, and then you just do whatever this is divided by, and we get our stuff here. So basically if we use part A, which x1 is equal to 1 here, as you can see, and this one has to equal 0, right? So as you can see, the error here is getting close, so it gets to 0 around, this is how many count here, scroll up, so this is count 40, so at x 40 it gets up to 0 here, and we get basically this number right here, 0.739085 here. And this one here we get, it takes a bit less here if we count. Let's just count from here to here. The difference is 6 here, so yeah, basically 6 iterations difference here, basically, because this one we started off with x is 0.75. It wasn't too big of a difference here, but regardless, they both converge around this point here. 0.739 is converged a bit earlier, so we'll just, yeah, this is 0.739085 is roughly the answer. Yeah, so we write down right here, the root of it is approximately this number here, and you could use the graphing calculator to confirm by zooming in and whatnot. But basically that's all for today. Next video I'm going to do one where this method doesn't converge and it doesn't work, or it just takes really long to converge here. Well, that's all for today. Hopefully you learned. You can download these notes as well as the Excel notes that I made just by clicking the Dropbox link below. Well, that's all for today. Hopefully you learned, and stay tuned for another math easy solution.